Get ready for a cosmic disaster on it. Scale never seen before. Betelgeuse, the red supergiant, is sending terrifying signals across the vastness of space. And astronomers are beginning to fear the implications. Using the powerful gaze of the James Webb Space Telescope, scientists have uncovered something profound about this aging stellar behemoth. Even renowned physicist Brian Cox has issued a serious warning. The questions stirring intense debate in the scientific community and among space enthusiasts is simple but alarming. We about to witness a supernova explosion so massive that it will alter the night sky forever? In the endless dance of cosmic birth and death, stars follow spectacular life cycles. Right now, Betelgeuse may be approaching its grand finale. Positioned prominently in the constellation Orion, Betelgeuse has always drawn attention for its distinct reddish hue and peculiar variability. However, recent developments have escalated that interest into urgent concern. Changes in Betelgeuse's behavior are hinting at a significant transformation that may be nearing. Could we be standing at the brink of a celestial event unlike anything humankind has ever witnessed? Betelgeuse is not just any star. It is a true titan among giants, roughly 900 times larger than our Sun. Its colossal size defies comprehension. Betelgeuse were placed at the center of our solar system. Its surface would extend past the orbit of Mars, swallowing Mercury, Venus, Earth, and the red planet in its glowing embrace. Such immense scale is a clear indication of the star's age and evolutionary stage. Betelgeuse is nearing the end of its life, having exhausted the hydrogen in its core and now undergoing fusion of heavier elements. Estimated to be between 8 and 8.5 million years old, this ancient star has already experienced dramatic changes during its lifetime, evolving into the red supergiant we observe today. In this late phase, it is expanding and cooling, final act before the inevitable collapse. One of the most defining features of Betelgeuse is its deep red color, which is due to its relatively low surface temperature compared to stars like our Sun. While the Sun's surface burns at approximately 5,500 Kelvin, Betelgeuse glows at a cooler 3,500 Kelvin. This lower temperature causes it to emit light primarily in the red and infrared spectrum. But this reddish tint is more than cosmetic. A window into the star's physical condition and the processes raging within its vast turbulent atmosphere. Interestingly, historical records suggest that Betelgeuse may not have always appeared so red. Ancient Roman and Chinese texts describe it as yellow, and it wasn't until around the 9th century that Arab astronomers began referring to it as red. This evolving color may indicate real physical changes in the star's structure and temperature over centuries. Another fascinating characteristic of Betelgeuse is its brightness variability. It is classified as a variable star, meaning its brightness fluctuates over regular cycles. Betelgeuse has a primary cycle of around 400 days and a longer secondary cycle of approximately 5. This rhythmic brightening and dimming has intrigued observers for centuries. Sir John Herschel documented these cycles as early as 1836. There's evidence that Aboriginal Australian lore may include oral traditions referencing Betelgeuse variable nature. Yet what truly sets the star apart is the irregularity that occasionally disrupts these cycles. Unlike many variable stars with predictable patterns, Betelgeuse sometimes dims unexpectedly, defying astronomers' models and hinting at complex, poorly understood phenomena within its chaotic interior. In late 2019, Betelgeuse shocked the world with an unprecedented event now known as the Great Dimming. as one of the brightest stars in the sky and a key marker in Orion's shoulder, Betelgeuse began to fade noticeably and inexplicably. The light output dropped rapidly, dimming at an average rate of 0.01 magnitude per. By February 2020, it had become so faint that casual observers could visibly notice the difference in the night sky. For a time, it seemed as though Betelgeuse might be on the verge of going supernova. But there's a frustrating obstacle to real-time observation of stars like Betelgeuse. The light we see from it is already over 650 years old, situated approximately 654 light-years from Earth. Any event we witness now actually occurred in the 14th century. This time delay makes it extremely difficult to determine what is happening in the present and complicates predictions about the star's imminent. The 2019 dimming event prompted astronomers worldwide to turn their telescopes toward Betelgeuse, searching for answers. Andrea Darai, deputy director of the Harvard-Smithsonian Center for Astrophysics, led a detailed study over 3 years analyzing data collected by the Hubble Space Telescope. The goal was to understand the changes in Betelgeuse outer atmosphere and what might have triggered the dramatic drop in brightness. Hubble's sensitivity to ultraviolet light allowed Dupree's team to monitor swirling convection cells and turbulent surface activity that influenced the star's brightness. The observations revealed something startling. Material was moving outward from Betelgeuse's surface at speeds exceeding 200,000 miles per hour. These gas flows eventually reached millions of miles beyond the star, contributing to the formation of a massive dust cloud. The dust cloud is now believed to be responsible for the Great Dimming. According to Dupree's findings, unusually large amount of material, twice the typical volume, was ejected from Betelgeuse's southern hemisphere. This material cooled and condensed, formed a thick shroud of dust that obscured the star's light, creating the illusion of a dimming star. But even with this explanation, many scientists remain unsettled. The mass loss was extreme, and the speed of the ejection was unexpected. Events of this magnitude are rare, especially from a star not yet in its supernova phase. Some researchers are beginning to wonder if this could be prelude to something far more significant, a precursor to collapse. If Betelgeuse were to go supernova, the event would be visible from Earth with a naked eye. Even during daylight, it would shine brighter than the full moon and cast eerie shadows at night, visible across the globe for weeks or even. For astronomers, such an explosion would be the observational opportunity of a lifetime, providing valuable data on the end stages of massive stars and the mechanisms behind supernovae. However, despite all the excitement and speculation, no one can say for certain when or if Betelgeuse will explode. It could happen tomorrow, or it might not occur for another 100,000 years. The irregularity of Betelgeuse's behavior, the recent mass ejection, and the Great Dimming all suggest that the star is unstable, but instability does not always mean imminent collapse. Supergiants like Betelgeuse often go through turbulent phases in their final stages. And what we observed in 2019 may be one of many chaotic outbursts to come. The mystery deepens as astronomers continue to analyze data from the James Webb Space Telescope and other observatories. Advanced infrared imaging has provided even clearer views of Betelgeuse's outer layers and surrounding environment, revealing new patterns of convection, plasma movement, and mass shedding. These insights are gradually painting a clearer picture of a star teetering on the edge of something monumental. Some theories propose that Betelgeuse might be in a phase known as the silicon burning stage, a critical, short-lived period that immediately precedes core collapse. Through this, would suggest that the end is indeed. Others caution that red supergiants can fluctuate wildly in their twilight years without necessarily exploding. As the world watches and waits, Betelgeuse continues to flicker in the sky, a luminous question mark in the cosmos. The truth is, we may not know what is happening inside this ancient star until it finally erupts in a burst of energy so vast it will outshine entire galaxies. Until then, remain observers, tracking its every twitch and shimmer, aware that we are witnessing a celestial drama billions of years in the making. Whether Betelgeuse explodes next week or next millennium, one thing is certain: it has already ignited a global fascination with the fragility and grandeur of stars. It has reminded us how little we still understand about the forces shaping our universe. Despite the uncertainty surrounding Betelgeuse's fate, astronomers continue to monitor its every move with growing anticipation, aware that its unpredictable behavior could reveal the secrets of how massive stars end their lives. Betelgeuse is not just a giant, it is a cosmic ticking clock. In every dimming episode, every flare of ultraviolet activity could potentially be a prelude to something far greater. The James Webb Space Telescope, JWST, with its unparalleled sensitivity in the infrared spectrum, has become a key tool in unraveling this mystery. Unlike optical telescopes, JWST can peer through the clouds of dust that surround Betelgeuse, revealing structures and dynamics within its outer layers that have never been seen before. Recently, JWST detected complex shock waves rippling across Betelgeuse surface, massive undulations in its photosphere caused by internal instabilities and convective currents. These shocks could be signs of powerful nuclear reactions deep within the star, heating and displacing material in unpredictable waves. One particularly intriguing finding from JWST data is the asymmetry in Betelgeuse's atmosphere. Rather than maintaining a uniform spherical shape, parts of the star bulge outward while other regions appear sunken or flattened. This uneven surface may be the result of enormous convection cells, gigantic bubbles of hot plasma rising and falling across the star's outer shell. These convective bubbles, each potentially the size of our entire sun, churn slowly and release tremendous amounts of energy, contributing to Betelgeuse's irregular light curve. The presence of such features hints at extreme internal pressures building within the core. If those pressures reach a critical threshold, it could trigger a gravitational collapse, the starting point of a supernova. But the exact tipping point remains elusive. A known model can perfectly predict when a red supergiant like Betelgeuse will transition from instability to explosion. In this cosmic theater, are mere spectators watching a slow motion drama unfold with tools more advanced than ever before, but still ultimately limited by distance and time. While many astronomers remain cautious